Okay, now let's look at a couple examples using the terminology that we just talked about for set notation. So here's the first example that we'll do. So draw a Venn diagram that represents the sets that are shown below. Okay, so here we're given that our universal set will be 0, 1, 2, 3 on up to 20. So what we're essentially doing is we're narrowing down all the numbers that we're considering. We're only looking at the integers from 0 to 20. Okay. So set A will consist of the multiples of 3, set B will consist of the multiples of 4, and set C will consist of the multiples of 7. Okay. So usually what I do when I am asked to draw a Venn diagram and I'm given the set listed like this is I will find out what elements are in each set first. Okay. So remember, I'm only considering the numbers from 0 to 20. So the multiples of 3 then, well, my first multiple of 3 would be 3 times 1, which is 3. My second multiple of 3 would be 3 times 2, which is 6. 3 times 3 is 9. So I'm going to go up until I hit max out at 20. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21, but we're only going up to 20, so that means 18 is the last multiple of 3 that we're going to have here in this set A. Set B would be your multiples of 4. Alright, so same way. So multiples of 4 will be 4 times 1, which is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. I can go up to 20 because 20 is in the universal set. But of course that's going to be my last number in that set, so that's set B. Set C would be the multiples of 7, so my multiples of 7 would be 7 times 1, wow, that's horrible, which is 7. 7 times 2, which is 14. 7 times 3 is 21, which is not inside of this universal set, so I cut it off right there. Alright, so I'm going to draw a Venn diagram. So the first thing I do is I draw my universal set. So my universal set is just going to be a big rectangle. So here's my universal set. Inside of this rectangle, I've got the numbers from 0 up to 20. Okay? And then I'm going to have set A, set B, and set C. So I need to try to get an idea of what this thing looks like. Okay? So here's what I will do. I will say, okay, I'm actually going to look at set C first. And the reason that I'm going to look at set C is because it has the least number of elements. So 7 and 14. So first of all, I'm going to try to see if I have any subsets here. So does 7 show up in either of set A or set B? Well, it doesn't show up in set A, doesn't show up in set B. Okay, so it's probably not going to be a subset of A or B. How about 14? 14 doesn't show up in A, nor does it show up in B. So what I actually see here is that the two elements that are inside of set C don't show up in either A or B. Okay? So what I really see there is if those C has nothing in common with A and C has nothing in common with B, then I actually know that C and A are disjoint sets. That means they have no elements in common. And C and B are also disjoint sets. Okay, so when I go to draw my Venn diagram circles, I know that C and A will have no intersection point, no crossover. C and B will have no intersection points, no crossover area. Okay? So essentially, set C is going to be all off by itself to the side. So I can actually draw that now. So I can say, alright, here's set C over here. I know that it has nothing in common with the others, so I can just say, alright, the elements that are in here are just going to be 7 and 14. Okay? A and B will probably be over here somewhere where C is hanging out on the side. So A and B, do these have anything in common at all? Well, let's look at B because it has fewer elements again. 4 doesn't show up in A. Alright. 8 doesn't show up in A. But I've got 12. Alright, so 12 shows up in A and B. 16 doesn't show up in A, and 20 doesn't show up in A. So I see that for sure B is not a subset of A because not everything that's inside of B shows up in A. So these are not subsets for sure. But what I do notice is that they have this element in common. So that means there is going to be some kind of crossover area when I draw my Venn diagram. And it's going to be actually only the element 12. Okay? So when I draw A and B, it'll look something like this. So I'll have set A something like this, and set B something like that. There's a little bit of an intersection here, a crossover area, representing the element that shows up in both sets. So I could have set A here and B there. So set A has the numbers 3, 6, 9, 12, 15, 18. So I can start listing these. I've got 3 that's in A but not in B. 6 is in A but it's not in B, so I'll again list it over here. This is the area that's in A but not B. 9 is in A but not in B, so 9 goes here. 12 is in A and B, so that means the 12 actually goes in here, the intersection or the crossover. 15 is in A but not B, so that actually goes back out here. And 18 is in A but not B, so that goes out here as well. For set B, I've got the number 4. It doesn't show up in A. I've got the number 8 that doesn't show up in A, 16, and 20. So our Venn diagram looks just like this. So I can see that there are no subsets here. There's no circle completely inside of another. There are some disjoint pairs, disjoint sets. These are your disjoint sets because they have nothing in common. A and B do have one element in common, and that would be what our Venn diagram looks like. Okay, so let's look at another example now. So this is a second example, which is similar to one of the assigned questions. So let's consider the universal set to be the numbers from 1 to 10,000. So I'm not going to draw this. Well, I'm not going to draw every element because 10,000 numbers are a lot. So set A is a subset of U. So that means I've got a universal set. Inside of that universal set, I've got some set called A. I'm not told much about A, but I just know that it's inside of A. So I can roughly draw what this looks like. Here's my universal set. And I just know that whatever set A represents, it's in here doing whatever it does. Okay? So that covers the first two pieces. And I know, of course, that the number of elements in here, it's going to be 10,000, right? Okay? Because I've got the numbers from 1 to 10,000 inside of this rectangle. That means there are 10,000 numbers inside of this rectangle. Of course, not all of them are in A, right? Some of them are going to be out here, some of them are going to be inside of A. Well, I'm actually told that the number of elements that are in the complement of A, that's what that symbol means, right? The number of elements that are in the complement of A, which really means the number of elements that are not in A. So the number of elements that are not in A is 50. So of the 10,000 elements that are in here, the universal set, I know that there are 50 that aren't inside of A. So that means out in this area here, I have 50 of the 10,000 elements. Okay? Now it's asking me to determine the number of elements that are in A. Well, if I know that this rectangle has 10,000 elements, this area outside of the rectangle has 50, outside of the circle, sorry, has 50, then that must mean, since these are the only two sets involved, U and A, that the rest of the 10,000 must be in here, right? So I can say, okay, that the number of elements that are inside of A must be the number of elements that are in U minus the number of elements that are not in A, which in this case would just be 10,000 minus the 50, okay, which is of course 9950. Okay, so that's a couple of examples on that section. It probably would be good for you to have a look at example 1 as well. I didn't want to do that one exactly, but that one's kind of similar to the first one that we did. And let me know if you have any questions.